Great. That was a lot of things that we consumed in the previous session. We are not done because we haven't gotten the basic grasp of atomic stability, but we are getting there. So in this session, we are going to continue from where we left off. Let's go back to the periodic table that we were studying from. So this is the periodic table that we had, and then we talk about the period, the number of shells. We were using boron as an example to illustrate how to relate the group and the period to the shells and valence electrons, right? Yeah, we did that in the previous session. So in this one, let's build on getting nearer to understanding atomic stability. We say group 1 element have how many number of valence electrons? 1. Group 2 element have 2, 3, 4, 5. So the number of the groups tells you basically the number of valence electrons of the element in that particular group. If it is period, the period tells you the number of shells those elements in that particular row have, right? Elements in that particular period have. Okay, so now let's look at something special about atoms. They all want to attain stability, right? Aside the period, those that are in period 1, that's hydrogen and helium, aside them, the rest are focused on trying to reach the octet rule, meaning that they want their valence shell to be having a maximum electron of 8. That's the basic thing. There's more to that when we come to the orbitals and all that, but for now at this level, let's understand that let's just have it that the others, aside those in period 1, that's hydrogen and helium, the others want to follow the octet rule, meaning they want to have a maximum of 8 electrons on their valence shells. If you go to the hydrogen and helium, they want to focus on the doublet rule, where they only have the K shell, and the K shell can host only a maximum of 2 electrons. For that reason, they toggle between 2 electrons and 1 electron, right? So hydrogen has 1 electron which is on the first shell, and that's it. Helium has 2 electrons on the first shell which is stable. That's stability from the doublet rule, right? That's fine for helium. So that's why helium is in the stable state, in the stable group. That's all group 8 elements. We call them noble gases. They are the stable gases. They are the inert gases. They are stable. We basically have it that they have their valence electrons to be fully stable, 8 exactly, or 2 for helium, right? So they are stable. They don't try to get stability. They are already stable, so they don't even try to compete for stability. They don't even do anything to do stability, right? But then let's look at the other ones that don't have the full ones. So let's start with group 1. Group 1 element have what? 1 electron, right, on their valence shell. So I'm just drawing the valence shell. So any member of the group 1, right, who have a valence shell and there's only 1 electron, the cross is an electron, right? So any of them, so we don't care the number of like core shells. So those ones, the core shells are always full before we get to the valence shell. It's the valence shell that is deficient of electrons. It's the one that is having electron being 8 or not. But before you get to the valence electron, all the inner shells are fully filled. As for them, they are already stable. So what happens is that it's the valence shell that we are interested in. So all the elements in the group 1, regardless of the number of core shells that they have, the inner shell that they have, they are going to have the outermost shell. We are interested in the outermost shell, and the outermost shell is going to have 1 electron. Okay, so now how do we attain stability? We want the valence shell or the outermost shell to have 8 electrons, right? But they have 1. It means that they need to go and borrow 7, right? Because 1 is left with 7. We need to get some 7 electrons from somewhere and add to the valence shell to make them stable. That's 7. 7 is a lot. Getting 1 electron is not easy. We are going to learn some energy, like energy and all that, and realize that and electron affinity, all that, right? You're going to be a lot of electron need to buy from somewhere. It's too large to go and get those numbers, right? 7 electrons, that's too much money for the atoms, right? But then we know that the shell, or the shell just before the the outermost shell is probably stable. It's probably stable because inner shells might be stable, might be fully filled before you get to the outer shells. So the one that is inside here may have already 1, 2, 3, 4. 1, 2, 3, 4. So the one that comes before the valence shell for each of them, right, is already stable. It's already stable. So the electrons are like, to attain stability, instead of going for 7 more electrons, I can just lose this one electron. I can just get rid of this one electron somewhere, like minus this electron. The electron should go. If this electron should go, meaning the outermost shell will be now free. That will get rid of. Our stability will not depend on the outermost shell again. Then it's like the outermost shell will get rid of the outermost shell. The outermost shell will go because the electron will be gone. Then what will happen is that the next shell below it, right, the one that before the original valence shell, will now become the boss. Will now become the outermost shell now. So because the actual outermost shell in elements in group 1 is having 1 electron, but because of stability, because to attain stability, instead of going for 7 electrons to add to the 1 electron to make it 8, that's too much of electron. It's easier to just lose one, electron and still attain your stability by making use of the shell that is just before the outermost shell. So this one becomes now the outermost shell now after you have lost 1 electron. So basically, elements in group 1, they tend to lose 1 electron. They tend to lose that they are 1 electron. Instead of going for 7 to add, they just lose 1 electron and become stable. That's how they form ions, right? So elements in group 1, generally they lose 1 electron. And when we talk about electrons and formation of ions previously, you realize that you see the number of electrons should be equal to the number of protons. But when we are losing 1 electron here, what will happen is that the number of negatives will be less, right? Let's assume they were -4 and +4. If this one we lose 1 electron, it's going to be -3, +4, right? The answer will be +1. So this becomes the charge on elements in group 1. So if I take lithium, for example, so lithium will have this plus, lithium plus, sodium will have Na plus. So it's just basically, so this is their stable form. They form ions then. So group 1 element tends to lose 1 electron to become stable. Group 1 element tends to lose 1 electron to become stable. What do you think of group 2? Group 2 also have 2 electrons, right? This one, they will lose 2 electrons, right? That's why you have something, when they lose, the proton number in them become more. So the positive sign. So the calcium, if we see calcium 2+, this is a stable form. So the ion, magnesium 2+, Mg 2+, right? It becomes stable. So they lose the electron, that particular 2 electrons to become stable. And group 3, aluminum 3+, Al 3+. So they lose 3 electrons, right? Group 1, group 2, group 3, they lose 3 electrons. Now we get to group 4. Now group 4, hey, these guys, they have 4 electrons on their outermost shell, and they need 4, right? They have 4 electrons on their outermost shell, and they need 4. So either way, they either go lose all the 4, or they go and just get 4. Either way, you are going to use the same amount of energy in losing or in gaining. But then everybody would like to gain, right? We like to add more to ourselves. So from group 4, right, these guys begin to, instead of losing their electrons to be stable, they rather gain electrons to be stable. Because group 4, right, if I'm going to lose 4 electrons and I'm going to use some energy to lose 4 electrons, I'm going to use the same energy to gain 4 more electrons for my outermost shell to become 8 and be stable. I'll just keep my 4 electrons and use that energy to rather get more electrons. So that's what they do. They tend to get 4 electrons, right? So that's how carbon. So we have carbon 4-, right? 4-. So they will go and get 4 electrons and add to themselves, and nitrogen N3-. Nitrogen is in group 5. And nitrogen is in group 5, meaning it has 5 electrons on its valence shell. How many is left for nitrogen to reach 8? It's left with 3. So instead of losing 5, they just rather go and fight for getting extra 3. So these guys that are here, right, they all want to gain more. They fight to gain more. But then for the group 1, group 2, group 3, they tend to just release the fuel that they have in order to be stable. But from carbon going, from group 4 going, either way they will lose. What happens is that they rather go and get more. So they tend to take more electrons. When they take more electrons, there will be more negative than the positive in them. At the end of the day, that's why they have the negative negative signs. These guys, we call them what? Non-metals. These guys usually form the non-metals. So let's take group 6, oxygen. Group 6 oxygen, 6 electrons, right, on your valence shell. You need to just 2. So you'll be seeing oxygen being O2 minus. O2 minus. You go and take extra 2 electrons to become stable. Let's talk about the fluorine, chlorine, and bromine. So fluorine will be seeing F minus. Fluorine is in group 7. They are in group 7. So if they have 7 electrons, they only need 1. So they are more likely to go and fight for 1. So they form the F minus. So they just get 1 electron instead of losing the 7, get 1 electron to become stable. So that's basically how these guys form the ions and then losing electrons on all that, right? Yes. So for the group 8, as for them, they are 8 already. So the inert gas, they don't react, they are unreactive, and they are stable already. They don't fight to be stable. They are okay with what they have, right? That's it for this particular session. So this is the basic idea you have to why they are losing electrons. Some are forming positive charges, some are forming negative charges. The reason is because of loss or gain of electrons, which is basically the basis for forming ions that we've discussed so far. See you in the next session where we continue to build on how to combine these substances and see how they play role together in order to form stable substances together for us to use. See you in the next session.